All right, here's a couple of questions that deal with exponential and logarithmic functions. First one's an equation. And to solve this, what we want to do is express each factor as the same base. So this is the same base, that's the type of equation you want to do. So 27 is the same as 3 cubed. 3 to the 5x, it's already with the right base. But then 9 should be written as 3 squared to the x squared. Okay, this is a power of a power, so I'll just rewrite that. Times 3. So 2 times x squared would just be 2x squared. Now here, careful with this one, because here I have one where the bases are the same and I'm multiplying. So like if I have x squared times x to the third, that's the same as x to the, what do you do with those exponents? You want to add them. So you have to do the same thing here. So this would be 3 cubed equals, here I'm multiplying common bases, add their exponents. So it would be 3 to the 5x plus 2x squared. Okay, now I have the same bases, so I can just focus on the exponents. So if this is the same as this, it means I can equate those exponents. So I have 3 is equal to 5x plus 2x squared. It's a quadratic, so let's bring everything to the right side and make it equal to 0 because it's quadratic. Now I'll try and factor it. I think 2x and x. I'll probably be putting a plus 3 there and a minus 1 there. Does that work out? 2x squared plus 6 minus 1, yeah, that's 5, and minus 3, yeah, that's correct. So therefore, let me just move up a little bit. Therefore, 2x minus 1 is 0, or x plus 3 is 0. So 2x equals 1, or x is equal to a half, and over here, x is equal to negative 3. Now, since these are exponential equations, I don't really have anything that won't work. So I think that both those numbers, 1/2 and negative 3, will work. You can try and check them. Always a good idea to check. Here's another question. And this one involves using the laws of logarithms. So here I've got the fourth root. So the first thing I would do is I would change that fourth root into a fractional exponent. So this whole thing that's inside here, x to the 8th b squared over y to the 4th z to the 16th, gets raised to the 1/4 power. Okay, and then that 1/4 power gets applied to each factor that's inside. So I have to apply it to this, to that one, and to that one. So I'd have log base b of 8 times 1/4 would be 2, so x squared. B squared times 1/4, 2 times 1/4 would be 2 over 4, or that'd be 1/2, I think. B to the 1/2 over 4 times 1/4, that would just be 1. And 16 times 1/4 would be 4, so it'd be z to the 4th. Okay, hopefully that makes some sense for you. Now, I can expand this out because this is being multiplied and divided, so I can use the product rule and the quotient rule to expand that out. Let me just do it up top here. So this would be log base b of x squared plus log base b of b to the 1/2 minus, because it's on the bottom, log base b of y minus log base b of z to the 4th. And then I'm pretty good there, but you can probably simplify it a little bit more. Like I can use the power rule to take that 2 and put it out front. So I'd have 2 log base b of x. Here, this is the sort of like the same base rule. If this base and this base are the same, your answer is just that top thing. So to what exponent is b raised in this expression? It's raised to the half. So that this whole thing would just be 1/2 minus log base b of y, and then I can bring this 4 out to the front. So it'd be 4 log base b of z. All right, hopefully that helps you with those two questions.